All right, you guys. So the next couple of lessons that we have are going to be applications of quadratic equations. And when we hear that word applications, it's really kind of telling us that, like, how does this apply to real world situations, or where could you use this in life? And that generally means word problems. And don't groan. I know that you hate word problems, but on the bright side is, we don't always do word problems every day. We just have a couple lessons every now and then where we have to do word problems, and you can do it. And for those of you who are distance learning right now, just really try your best. It's not as bad as you think. You have all the skills to solve these word problems. They're not as bad as you think. So let's take a look at this. On number 1, it says the width of a rectangle is 6 meters less than its length. So let's just start right there. What we know so far is that we have a width and we have a length. And it's telling us that the width of the rectangle is 6 meters less than its length. So for me, whoever we are comparing to, that's like the original. That's who gets to be x. So the length we're going to say is x, and we're going to translate the width. The width is 6 meters less than the length. So that less than is a turnaround phrase if you remember from previous math classes. It's not going to be 6 minus x, it's going to be x minus 6. So let's think about, again, what that would look like right now. We have a rectangle. We know that the length is x meters long, and the width is x minus 6. And let's keep reading to find out what else it will tell us. The area of the rectangle is 112 meters. Find the dimensions of the rectangle. So again, right here, we're going to say the area of this is 112 meters long, or not long, but inside of it. Okay, so we are being asked to find the dimensions. What is the dimension or the number of the width? What is the number that equals the length? Well, let's talk about things that we already know about rectangles. We already know that there's a formula that tells us how to find the area of a rectangle. The area A is equal to length times width. Okay. And we have all three of those pieces, so to speak. We have a length of x, a width of x minus 6, and we know the area is 112. So we could then rewrite this as, this whole problem from the rectangle we have above, as our length of x times our width of x minus 6 is equal to the area of 112. All right, now here's the thing, when we're solving these application problems, what we're going to do is multiply it out, get it set equal to 0. Okay, that's a big thing. Always get it back set equal to 0, and then we're going to refactor or apply the quadratic formula and to find our solutions. So our first step here, we're going to multiply out the left side, and we get x squared minus 6x, and we're still equal to 112. Again, the big thing here is we need it set equal to 0. So we're going to minus 112 from both sides. Okay, so now we have x squared minus 6x minus 112 is equal to 0. Okay, that's a big thing. Always get it set equal to 0. If you try to refactor when you are not set equal to 0, you're just going to go back to the same problem you had, which really just doesn't get us anywhere. So now what we're going to do is we're going to try to factor this and solve for x. Again, we're trying to get an answer for x, which is our length, and then will help us find our width. So what we have here is x squared minus 6x minus 112. We have 1, 2, 3. We can use our factor tree to help us solve this. What multiplies to negative 112 and adds to negative 6? Now again, I'm teaching this lesson, and so I can't really get a lot of interaction from students, so I'm just going to go ahead and get to the answer, which would be negative 14 and positive 8. We've talked a lot about how you can use trial and error to help you find those two numbers. Try that when you're working on these things. And we would rewrite it as factors. X minus 14 times x plus 8 is equal to 0. And it's the same thing we always do when we're in this situation. We're going to t-bar. We're going to set each factor equal to 0 and solve for x. So if we have x minus 14 equals 0, we would solve for x by adding 14. Okay, so we would get one solution of x equals 14. we would subtract 8 from both sides and get x equals -8. So we have two possible solutions, and I'm going to write them over here on the side. Okay, we have an x equals 14, x equals -8. Now remember, the length of one side is x. So out of these two choices, one of them is going to be like not working, okay? We're going to cross off here x equals -8 because our length, our measurement can never be the negative number, okay? So if we have just an x labeled at that side and we say x equals a negative number, we get to cross it off because that does not make any kind of logical sense to be equal to a negative value. So we're going to say x equals 14. But remember, the question was asking us for the dimensions. So if x is equal to 14, that's the length. We're going to find the width by doing 14 minus 6, which equals 8. All right, so we just kind of computed the two sides. You did that a lot in geometry, so it's not so bad. So we're going to say for our answer here, the length is 14 meters, and the width is equal to 8 meters. Hopefully you didn't feel like that was too terrible. We're going to keep practicing. It gets better. All right, so we'll move on here in just a second. Okay, on number 2, it says the length of a rectangle is 1 foot more than twice its width. So let's go over here to the side and we're going to label length and width. Now it's telling us that the length is 1 more than twice the width. We are comparing to the width this time. So we're going to say the width is x. Again, the one we compared to gets to be x. The length is 1 more than twice the width. We would say twice the width would be 2x and then plus 1. If you wrote 1 plus 2x, it'd be the same thing, but I like having my x's more to the front. So again, this rectangle, what do we have? We have a rectangle, and the length is 2x plus 1. The width is x. That's what we know so far. And then it goes on to tell us that the area of the rectangle is 300 feet. So the area of the whole thing, the length times the width, equals 300. So again, that's a big thing. There's usually a formula out there that will help us solve all this. Again, that would be area is equal to length times width. You've known that since you were like in grade school here. So let's plug that all in. And remember, I'm kind of showing it as maybe width times length equals area, but that is the same thing. We can rearrange it. I like to be equal to the number and have my x's on the left side, and that's fine. So we're going to say that x times 2x plus 1, the two sides, again, multiply, and I'm showing that's multiplication here on the left, is equal to the area of 300. So again, your step, and it should be very visual to you at this point. What can we do with an equation like this? Well, we could multiply. We can distribute x. That's not too scary. So x times 2x is 2x squared, and then x times 1 is 1x, and we are just equal to 300. But again, we want to set equal to 0. And I'm going to write that out here. That's always what you have to do before you can try to solve any of this. Get it set equal to 0. So we're going to minus that 300 to both sides. And he doesn't have a like term to go with, but we're going to make sure we're in standard form, that we're in the right order here. So we have 2x squared plus x minus 300 is equal to 0. So what can we do at this point? Well, there might be lots of different solving methods. Again, quadratic formula always works. Sometimes that's a little messy, but we could do our 1, 2, 3 factor tree. This would just be a slider because we have a number in front of x squared. We're going to slide and multiply 2 times 300 because it's not coming out as a GCF. All right, we can't take 2 out of 1. So we have x squared plus x minus 600 is equal to 0. So we're going to do 1, 2, 3 factor tree. What multiplies to negative 600 and is going to add to negative or positive 1. Okay, so those numbers have to be 1 away from each other. Ooh, so we're looking for numbers pretty close. And that would be, let's see, it's going to be 25 and a negative 24. Okay, 25 times negative 24 multiplies to negative 600. 25 minus 24 equals positive 1. So we will rewrite this now as x plus 25 times x minus 24 equals 0. But remember, if we slide we have to undo that and divide at some point. We're going to divide 25 and negative 24 by our slider by 2. All right, so I'm going to kind of go up over here. Now, 25 over 2 does not simplify, so I'm going to leave it as x plus 25 over 2. And then negative 24 over 2, that's going to simplify to negative 12. So we have x minus 12 equals 0. And again, once we've factored, we always do the same next step after that. We t-bar to separate our two factors. Each factor gets set equal to 0, and we solve each of these factors for x. So here we would subtract 25 halves from both sides. And one solution, possible solution, would be negative 25 halves. My other solution, for my other side of my t-bar, we're adding 12 to both sides, and we get x is equal to positive 12. Now remember, I'm kind of circling this right here. One of the sides' lengths is x. So length can never, or width can never be negative. So we get to cross off the negative 25 halves, and we're going to say that the width here, because it is x, is equal to 12. What does that make the length? Well, to find the length, we are doing 2 times x, which we know is 12, and adding 1. So that'd be 24 plus 1, which equals 25. So our length is equal to 25 feet, and our width is equal to 12 feet. Again, we set it, put it into the formula that applies. Again, that was length times width equals area. Okay, we substitute those values in for what we know so far. We multiply, we set equal to 0, we refactor. Now again, if you hate factoring, you could have done quadratic formula, and it would have told you on quadratic formula 12 and negative 25 halves, and you would have just kept the 12. There is more than one way. Again, I just like to use factoring when it does work. And we will keep on going. All right, on number 3, we have the dimensions of a rectangle can be expressed as x plus 6 and x minus 2. So let's draw a little diagram, make a little rectangle. It's nice to have visuals. We've got one side that is x plus 6, another side is x minus 2, and it doesn't really matter which one's which because they both multiply to make the area. We're saying that the area, when these two are multiplied, they make a total of 65 inches squared. All right, so we have our two sides. Again, we're still knowing that a length times a width equal an area, okay? So let's plug in that information. We know that x plus 6 is one of our sides. We know that x minus 2 is another. And if those are multiplied, and again, that's why I'm showing these in sets of parentheses now, and they are touching to show that they're being multiplied, it equals the total area, which is 65. And again, looking at this, it would again be logical to me that the only thing we could do here is to FOIL out, multiply x plus 6 times x minus 2. So we're going to multiply x times x to get x squared. X times negative 2 is negative 2x. 6 times x is 6x. 6 times negative 2 is negative 12. This equals 65. Okay, don't forget that your middle two terms will combine. You need to do that before you move on. We also need to get this set equal to 0. So we're going to minus 65 from both sides, and it will match up with the other constant. So simplifying this all together now, we have x squared plus 4x minus 77 is equal to 0. Okay, again, you have to get it set equal to 0, or else you're just going to get right back to your starting point. It's going to feel very frustrating if you do that. So now I've got 1, 2, 3. We can do factor tree here. Again, if you like quadratic formula, you can pick that. You're allowed for these. We're asking what multiplies to negative 77 and adds to 4. And this one's not so bad. This one is actually just going to be 11 and negative 7, right? 11 times negative 7 makes negative 77. 11 minus 7 is 4. We'll rewrite this as two factors. X plus 11 times x minus 7. It's equal to 0. Remember, we have this set equal to 0. That's essential. Then we're going to t-bar. If we have x plus 11 equals 0, we would subtract 11. And one possible solution would be negative 11. If we have x minus 7 equals 0, we're adding 7 to both sides. So we're going to say x equals 7 is one of our possible solutions. Now, because one of our sides is not just x, we're kind of having to check both. Okay, what's negative 11 plus 6 if we plugged it in? That's negative 5. And again, that's going to make a negative length when we test it, so we're going to cross it off. So remember, one of our sides, okay, our length was x plus 6, so we need to plug in the 7. Okay, we're going to say 7 plus 6 to get 13 inches for our length. Okay, that's 1. And then our width was x minus 2, so we're subbing in 7 for the x. 7 minus 2 is 5. So our dimensions are 13 inches by 5 inches. So number 4, we have the base of a triangle. So now we have a different shape here. We have a triangle is 7 less than twice its height. All right, so we have a triangle here. And we're going to be labeling, oh, things are moving around. We're going to be labeling the base, if it will let me, the base and the height. So it's telling us that the base is 7 less than twice its height. So the height here, it gets to be x. That's who we compare to. So we can label it in both places. The base is 7 less than twice the height. So turn around phrase because it said less than. So we have twice its height would be 2x and 7 less would be minus 7. So 2x minus 7 down here. Now, we're dealing with a triangle, and then it tells us that the area of the triangle, okay, is 102 centimeters squared. Well, we have a different formula when it comes to finding the area of a triangle. The area of a triangle is equal to 1/2 times the base times the height. And again, we have all that information to help us put it into this formula, all the pieces that we know. We're going to multiply it out, and then we could factor or use quadratic formula. And I think I'll use quadratic formula just for fun. So, and I like to rearrange it. Again, I want it to be equal to my area. So I'm going to kind of flip-flop these two sides. My area is 102. We'll put it right there. We're going to have 1/2. And my base and my height, again, order doesn't really matter. I like having the single letter on the outside of the parentheses and then 2x minus 7. Okay, all of these are being multiplied. Now, when it comes to multiplying, when you have more than just two things to multiply, we really got to chunk things out. So what I'm going to multiply first is the x times the 2x minus 7. We'll multiply that part first. And I kind of save that 1/2 for a minute. We're going to have that 1/2 hanging out on the outside. And I'm going to leave parentheses and distribute x times 2x to get 2x squared. X times negative 7 is negative 7x. I'm leaving that inside parentheses because I need to show that it's still going to get multiplied by 1/2. And this is still equal to 102. Okay, now we could distribute this 1/2 in, but it gets a little bit messy. So what I'm going to do instead is, I know it's being applied on the outside of the parentheses. We haven't put it inside yet. So we can do this. We really can. We can multiply both sides right now times the reciprocal, right? That's how we move fractions from one side of the equal sign to the other. I'm going to multiply by 2/1. See, because those cancel. Those make 1. That's a legal move right here. We're using the right order of operations. So we're just left with 2x squared minus 7x. Here we can drop the parentheses. There's nothing multiplying on it anymore. And it's equal to 102 times 2, which is going to be 204. All right. Phew, we got it all multiplied out. No more parentheses or anything. But remember, we have to get it set equal to 0. So we're going to subtract 204 from both sides. Doesn't matter what method you're using. You have to set it equal to 0. So this is 2x squared minus 7x minus 204 equals 0. Now this does factor. It would be a slider, but I just wanted to show it with a different method. And I'm going to use a quadratic formula. So I'm going to label my a, b's, and c's. A is 2, b is negative 7, and c is negative 204. So my quadratic formula, if you remember, is negative b plus or minus big square root b squared minus 4ac all over 2a. So when we plugged all this into the formula, we're going to get negative and then negative 7 plus or minus square root of negative 7 squared minus 4 times 2 for A times negative 204 for C, all being divided by 2 times A, which is 2. Now, again, it looks like a ton of you have been doing your IXLs like you've been expected to from home, and I love that. Now, if you have a Casio, like I told you, was a supply that you should have at the very beginning of the school year, you can type it in exactly like this into your Casio, or a graphing calculator if you have one, because it's fine to get decimals here, but you're going to use the plus sign the first time. Just make sure if you're using your Casio that you hit the fraction button first and then type it in just like this with parentheses, the radical, and everything. And then you're going to go back and you're going to change, just with your arrows, you can go and change that plus sign. You can delete it and you can change it to a minus sign and then hit equals again. Okay, and it's really simple and it's really fast, and there was no reason why none of you couldn't do that and then do your IXL. The two possible solutions you would get when you plug all this into the formula and compute and hit equals, just like I said, would be negative 17 halves, and you're also getting positive 12. Now, because one of our sides is x and we can't equal negative measurement, we're going to cross off our negative 17 halves. So cross off your negative. So we know that our height, which was x, is equal to 12 centimeters. Okay, so height is 12 centimeters, and our base is equal to 2 times 12, 2 times x minus 7. So 24 minus 7 is equal to 17 centimeters. And it was just asking us about the base right here. So that was 17 centimeters. And again, this would have factored too if you prefer to factor. So it's just a given. Some people really love the quadratic formula, and some people love to factor. It just depends on a personal preference right there. Okay, number 5, the hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the new triangle. Okay, so we know we have a triangle again, and it is giving us all 3 sides. Okay, it's not giving us an area, so we are going to have to use a little bit different formula here. We know that we have a shorter leg, and we have a long leg, and we have a hypotenuse. All right, we have those 3 that it talked about. Now, it compared everything to the shorter leg. So that tells me that the short leg gets to be x. Okay, so my triangle here, does it look, we'll just call this side the shorter side. And then the longer leg, it said, let's look at the labeling. The hypotenuse, okay, the longer leg right here is 7 feet longer than the short leg. So that will be just x plus 7 for my long leg, x plus 7. And then what is the hypotenuse? The hypotenuse is 1 foot more than twice the length. So that makes our hypotenuse just 2x plus 1. Okay, and we're going to, again, this is talking about a right triangle. So there is another formula that helps us here, again, because it did not give us the area. What we know is the Pythagorean theorem, yay, which is a squared plus b squared equals c squared, meaning your shorter leg squared plus your longer leg squared equals your hypotenuse squared. That's what all of this means. So we're going to plug these values in for what we know. The shorter leg for A means we have x being squared, plus our longer leg is going in for b. Okay, so it'll be A, B, and C. Our b value here is x plus 7, and we're going to square that, and it's going to equal the hypotenuse squared, which is 2x plus 1 squared. So this does look a little bit messy, I'm not going to lie, but we're going to just work it out step by step, and we'll get it done. X squared will stay x squared. Okay, now x plus 7 squared, maybe let's go off, okay, to the side here. Do I need to show it? Why not? I'm on a video. X plus 7 times x plus 7. If we FOIL this, we get x squared plus 7x plus 7x plus 49, right? And the middle two will combine. 7x and 7x make 14x. So when we FOIL out this piece right here, we're going to get x squared plus 14x plus 49. And this is going to be equal to 2x plus 1 squared, which does not mean distribute the squared inside the parentheses. That's a big no-no. That means 2x plus 1 times 2x plus 1. And we're going to FOIL this bad boy out. 2x times 2x is 4x squared. 2x times 1 is a 2x. 1 times 2x is another 2x. And 1 times 1 is just 1. The middle two still combined. And we have 4x squared plus 4x plus 1. So that's what this is equal to, 4x squared plus 4x plus 1. Now here's the big deal. This step is not going to change. We want it all set equal to 0. Okay, so let's talk about what does this make. X squared and x squared make 2x squared. So we have 2x squared plus 14x plus 49 equals 4x squared plus 4x plus 1. You should always combine all your like terms. You see how I acted like a squirrel? Got a little tangent right there. Okay, we always need the set equal to 0. I usually move everything to the left. Yes, I usually do that. But if you notice, right here, I'm going to use my highlighter, that 4x squared, okay, compared to 2x squared. If I minus 4x squared, I'm going to have a negative x squared. Ooh, and that's so hard to factor. So what I'm going to do is move everything to the side where my x squared term would stay positive. That's like an even better choice. So I'm moving everything to my right side. So we're going to minus 2x squared minus 2x squared. Cancels. Minus 14x minus 14x. Match it up with its like term. Minus 49 minus 49. What do we get? See, this is why I did this. This whole side canceled out to 0. As long as one of your sides is 0, you're just great. 4x squared minus 2x squared is still 2x squared. 4x minus 14x is negative 10x. And 1 minus 49 is negative 48. Okay, because it's set equal to 0, again, and if this offends your sensibilities, you could just kind of say equal 0 like this. It's the same thing, no biggie. We have a number in front of x squared, it's 2. Now, instead of sliding here, remember, we would always check, does it divide out? And we can take 2 out of everything here. So we're just going to divide 2 out. And I'm going to come over here to the side so I have more room. This gives me x squared minus 5x minus 24 equals 0. And this does factor. It's so nice and simple right here. We're looking for two numbers that multiply to negative 24 and add to negative 5. And that would be negative 8 and positive 3. And we would have x minus 8 in parentheses, x plus 3, it's all equal to 0. We would t-bar, and we're going to get x equals positive 8 and x equals negative 3. Now, I don't know how this looks on your screen. Oh, sorry if it's really tiny in the corner, if you can't see it. Doing my best here, I'm running out of room. Remember that we get to cross out the negative answer. So what we're keeping is x equals 8. So we want to know the dimensions. Who is 8? Well, 8 is x, your short leg. So we have 8 for the short leg. My long leg will be x plus 7, which is 8 plus 7, which equals 15. And the hypotenuse, we want its dimension, so we're going to do 2 times 8 is 16, plus 1 is 17. So that's all my dimensions right there in case you missed it. We have 8 for the short leg, 15, 17. Ta-da! All right, the height of a rectangle prism is 3 feet. The length and width can be expressed as x minus 1 and x plus 4. The volume of a prism is 198 feet cubed. Find the value of x. I'm not very good at drawing prisms, so I'm not going to draw it out. But the thing that we know is that the volume is equal to like the length times the width times the height, right? We multiply the 3 different dimensions. And so we have enough here. We know that the length and the width are each x minus 1 and x plus 4. The height is 3, and we have the volume, which is 198. So let's plug all that business in. And again, I like to set it equal to the number, to the volume. So we're going to say this is all equal to 198. And I'm going to start with my height, my one number, which is 3, times, remember, so it's 3 times x minus 1 times x plus 4. All three of those different dimensions are equal to the volume, again, which is 198. So we're going to have to kind of do this in pieces. Again, you always have to, if you have more than two pieces that are being multiplied, we have to kind of section it out. So I'm going to FOIL first. All right. So when I FOIL, we get x times x is x squared, x times 4 is 4x, minus 1x, and then we get minus 4. And we're going to combine our middle two to get x squared plus 3x minus 4. Okay, that's all going to be in parentheses still because we have the 3 that needs to be distributed inside, and we're still equal to 198. Okay, now we'll distribute the 3 into everything. We get 3x squared plus 9x minus 12 is equal to 198. So what do we do at this point? We need to subtract the 198 over. Okay, because it has to be set equal to 0. So we have a 3x squared plus 9x and negative 12 minus 198. Just let me, use my handy dandy calculator because I should be able to do this in my head. I just don't want to. So that's okay. I like calculators. Minus 198 is negative 210. It's equal to 0. Now before I do any method for solving here, okay, I'm going to look. I could do quadratic formula or I could do factoring. I've got this 3 in front of x squared, and it does go into all three terms. So let's make this all smaller. Dealing with smaller numbers is a little bit easier. We get x squared plus 3x minus, let's see, minus 70. Yep. And it's equal to 0. Oh, that's a much nicer set of numbers to work with. And I can just, even by looking at it, feel like it's going to factor. So I'm going to come back up here to the top, so maybe you guys can see better. X squared plus 3x minus 70 equals 0. Let's do our 1, 2, 3 factor tree, because remember, after we're set equal to 0, we have to refactor or find another solving method, which could be quadratic formula or complete the square, if you will, and solve for x. So what two numbers multiply to negative 70 and add to 3? Well, that would be 10 times negative 7, make negative 70. 10 minus 7 is 3. Writing it in factored form would be x plus 10 times x minus 7. We're equal to 0. We're going to t-bar, separate our factors, and set each factor equal to 0 and solve for x. We would minus 10 from both sides to get x equals negative 10 as one possible solution. We would add 7 to both sides to get x equals positive 7 as one of our solutions. So what is the value of x? Can we have our negative measurement here? No, let's cross him out. So x will equal positive 7. All right, number 7. We have this guy Ken. He has a rectangular shaped vegetable garden. So let's make us a little rectangle here. He's got this garden, and it is 15 feet by 9 feet. And he wants to increase the length. So increase is going to make it bigger. He's going to increase the length and width by the same amount, x, so that the new garden is twice the current area. So he's making this new garden. Let's show it. It's going to be bigger and better than the old garden. And he's increasing it by the same amount, x. And that is the unknown to us. So that means the original side of 15, he's adding x to it. And the width, he's adding x to it. And the area, the new area, we know is going to be twice the old area. Well, they didn't give us either of those numbers, so what do we do? Well, for the first area, okay, my little black rectangle here, we're just going to do 15 times 9. And 15 times 9 for the original area is 135. So now we know here that it told us that the new garden is going to be twice the current area. So we just have to do 135 times 2 to get the new area. So we'll know that the new area, 135 times 2, is 270. Okay, so what do we know now? Okay, we need to find out what x is. We want to know, okay, it says find x to the nearest tenth of a foot. We know that this 15 plus x times 9 plus x equal the area, right? Length times width equals area. Okay, that's a big deal. So it says x 15 plus x and 9 plus x. It doesn't matter. That's a commutative property of addition. I'm going to write it as x plus 15. And if we multiply it to x plus 9, because I can switch the order, it will equal the area, which we found to be 270. So the first thing we do, we multiply it out. I can FOIL over here on the left side. Okay, so let's change colors. X times x is x squared. X times 9 is 9x. Then we have 15 times x to get 15x, and 9 times 15 is 135. We kind of already knew that because we did it over here to find the original area, but that's okay if we didn't know that already. And it equals 270. 9 and 15, they're going to combine to make 24 x's. We have minus 135. And you know what? I can show it. You guys can handle this. We have to get this at equal to 0. So let's just go ahead and minus that 270 now. Okay, so what are we going to get? 135 minus 270 is just negative 135. And that makes sense because we just doubled that number. It equals 0. Now, we have a little bit of a clue here about which method would work best. It says to round our answer to the nearest tenth of a foot. Okay, that's the nearest, that's one decimal place. That tells me if we're getting, not integers, factoring is not going to work out so good. We're going to use the quadratic formula. So let's label our A, B, and C here. A is 1, B is 24. C is negative 135. And we're plugging it into the quadratic formula. So that would look like negative and then 24 plus or minus big square root. B squared is 24 squared minus 4 times 1 times negative 135. All of this is being divided by 2 times A, so 2 times 1. Again, I can't emphasize this enough. Use your Casio, just type it in exactly like this. First time you do it by addition, second time you'll do it by subtraction. Okay, just changing that sign. And we're gonna get 2 answers here. One answer would be rounded to the nearest, would be 4.7. Another answer would be negative 28.7. So remember, we do not keep the negative answer. So we're going to keep 4.7 is the value of x. Okay, on number 8, it says, given the diagram below, if the area of the shaded region, whoops, didn't mean to do that. Area of the shaded region is 59 inches squared. What are the dimensions of the outside rectangle? So you should notice here that we have 2 different rectangles, right? We have our outer rectangle here, and again, that is going to be its length times width would be 2x minus 1 times x plus 6. And it's only telling us that the area of the shaded region, all that gray business, is 59 inches squared. And then we have this white triangle taking up space, and its dimensions are x and x plus 3. And that's taking away from the shaded area. So what we should be picking up here, okay, here's my white triangle, is that if we take the area of what I highlighted in red, the outer rectangle, and we subtract the area of the white or the inner rectangle, we will be equal to the shaded region. That will be what's left, okay? So it will be equal to 59 inches squared. So what does that look like? The area of my outer rectangle is going to be 2x minus 1 times x plus 6, right? Multiplying the length and the width here. And if we subtract and say minus the area of the inside rectangle, which would be x times x plus 3, then we will equal the area of the shaded region, which is 59. All right. Now again, it is always the same steps, it's just a different arrangement. We are multiplying, we're setting equal to 0, we refactor and get our solutions. So 2x times x is 2x squared. Then we have 2x times 6 to get 12x. Okay, then minus 1x, minus 6. And I can keep working to the right here. There's more to multiply. Negative x times x is negative x squared. And then negative x times 3 is just minus 3x. It's equal to 59. We always combine like terms before we start doing anything else. So let's see, we have 2x squared minus x squared, so that will go together. 12x minus 1x minus 3x, and my negative 6. Okay, and that 59 here is going to kind of bump on over. So let's put everything together. 2x squared minus 1x squared is just x squared. Then we have 12x minus 1x is 11x. 11 minus 3 is 8. So we have a positive 8x. Now notice I just have this 1, negative 6. I'm going to go ahead and minus 59 so we can get this set equal to 0. Because we always need it equal to 0. And negative 6 and negative 59 are going to make negative 65. So minus 65, it's equal to 0 now. So once we've multiplied and combined like terms and got it set equal to 0, we can refactor now. So you could use quadratic formula, but factoring works here. We're looking for 1, 2, 3 factor tree, two numbers that multiply to negative 65 and add to positive 8. Okay, that will be 13 and negative 5. They multiply negative 65. 13 minus 5 is 8. So we write it as factors, x plus 13 times x minus 5, all equals 0. Then we t-bar. Each factor gets set equal to 0 and solved for x. So my two possible solutions for x are negative 13 and positive 5. All right, remember here, we do not want to keep the negative. Okay, we're going to cross off negative 13. X is 5, but that's not, it didn't ask us to solve for x. It asked us to find the dimensions of the outside rectangle. So we're going to plug in 5 and do plus 6 to get 11 for the length. And then we're going to do 2 times 5, which is minus 1. So 10 minus 1 equals 9. So what are the dimensions? The dimensions are 11 inches by 9 inches. Not so bad. Okay, on number 9, it says find two consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger integer is 24. Okay, so we're going to do some labeling here. We have our first consecutive odd integer, COI, and our second consecutive odd integer. So we're looking for two consecutive odd numbers in a row. We know these odd numbers both have to be positive. So remember, odd numbers are like 1, 3, 5, 7, 9, 11, and so on. Now here's the thing that we have to remember. Every odd number, like from 1 to 3, that is 2 numbers away from each other, right? We have to add 2. 3 to 5, we add 2. 5 to 7, 7 to 9. We're always adding 2 to get from one odd number to the next. That's really important here. So the first number we're always looking for, we get to label as x. It's the original number. But it's telling us to find two consecutive integers in a row. Consecutive, again, in a row. So if that first number I found was 5, well, the next consecutive odd number would be 7. If the first odd number I found was 13, the next consecutive odd integer would be 15. Okay, so we're looking for odd numbers in a row. So again, because all odd numbers are found by adding 2, we're saying that the second one is just x plus 2. Whatever the first number we find, we're going to add 2 to that. That's it. But this is important because we're going to use it to help us plug in and find what that value is, what those two numbers really are. So looking at this, it says here, such that the square of the smaller integer between x and x plus 2, x is going to be the smaller, so we're going to say, let's square that. The smaller number squared is x squared. And we're going to add to it, it says, added to 3 times the larger integer. So we're doing 3 times the larger would be x plus 2, is always means equals 24. So we just set it up as an equation, and we're good to go. What does it look like we can do here? Well, x squared is x squared, and then we're going to distribute 3 to get 3x plus 6. It's equal to 24. Not so bad. We have a quadratic now. We always get our quadratics after we multiply. We set them equal to 0, so we're going to subtract 24 from both sides. X squared plus 3x minus 18 equals 0. 1, 2, 3 factor tree. We're on a rhythm now. Oops, not equal to 0, equal to 3. What multiplies to negative 18 and adds to 3? We're going to say 6 times negative 3. Multiplies to negative 18. 6 minus 3 is 3. So in factored form, we would have x plus 6 times x minus 3 equals 0. We would t-bar. If we say x plus 6 equals 0, we would subtract 6 from both sides, and x equals negative 6. If we have x minus 3 equals 0, we add 3 to both sides and get x equals 3. So here's a key thing here. Yes, we're crossing off the negative because we want a positive number, but 6 is even. 3 is odd. Okay, so 3 is the first odd number. The second odd number would be found by doing 3 plus 2, which does equal 5. And again, that makes it work. Isn't 5 the next odd number after 3 anyways? So 3 and 5 are the two odd numbers that we were looking for. That's kind of fun. So number 10, we're finding 3 consecutive positive integers. So that just means 3 numbers in a row, one number right after the other. So that could be like any 3 numbers in a row, 5, 6, 7, 1, 2, 3, anything like that. But they do have to be positive, and consecutive means in a row. Okay, so we are going to have our first consecutive positive integer. We're going to have our second CPI and our third CPI. Now the first number we're always looking for, again, it just by definition, because it's the original, it's going to be x. So again, what if my first number was 1? Well, the second number would have to be 2. Compared to 1, 2 is just adding 1. So it's good. Second number is x plus 1. My third number, when we compare to the original, okay, my third number in this situation could be 3. From 1 to 3, we have to add 2. So it's your original plus 2 to get to your third number. Okay, so that's how we're labeling everything. Let's read the code to find out how we use this information to get our solution. So it says, such that the product, that means to multiply, of the median integer and the largest integer is 72. Okay, the median is your middle, so that's going to be x plus 1, and your larger is going to be the x plus 2. So it's saying product of those two things. We're going to multiply x plus 1 times x plus 2, and it's saying it when we multiply them, we get 72. That's not so bad at all. So now we're going to FOIL. We're going to get x squared plus 2x plus 1x plus 1 times 2 is 2 equals 72. So we have two things to do at this point. We're going to combine 2x and 1x, and we're going to get this set equal to 0, so we're going to subtract 72 from both sides. So we have x squared plus 3x, 2 minus 72 is minus 70 equals 0. So let's do 1, 2, 3 factor tree. What's multiplying to negative 70 and adding to 3? Well, that's going to be 10 and negative 7. We've had that on a different problem. That's cool. So we're going to write it as factors. X plus 10 times x minus 7 equals 0. Then we t-bar, separate the two factors. Each factor is set equal to 0 and solved for x. So we're getting here x is equal to negative 10, x is equal to positive 7. Well, we said our answer has to be positive. So our first number is x, and x right here is 7. The next number after that would be 7 plus 1 to get 8, and then 7 plus 2 to get 9. 7, 8, 9 are 3 consecutive positive integers. Okay, so again, tips for solving word problems. Label. Apply it to a formula then that you know. Okay, things like length times width equal area and so forth. You always multiply out the problem given, get it set equal to 0, then refactor or use quadratic formula to solve for your x values. Your negative answer usually is the one that you kick out, and sometimes we were solving for x, sometimes we're plugging it back in. But it really isn't as bad. You really need to give this a try because I know you can do it. And I am willing to help in any way I can. So good luck.